Hello, everyone. Can you all hear me good? Can you give me a thumbs up? All right, thank you. It's great to be here at droidcon, and thank you for joining today's session where I will talk about a few CI/CD strategies to make your development more efficient. I'm Naveen. I'm a solutions architect with Bitrise. At Bitrise, I work with customers to make their CI/CD setups run faster, and it's quite fun. Just a show of hands here. How many of you have used Bitrise in the? That's a pretty good number. Thank you. If you've not, you can apply the ideas that I present today and adopt it to other systems that you use as well. So let's start with this question to frame the session. Would you like to make your builds run faster or wait around for your builds to complete? I think the answer is fairly obvious. So let's now put some numbers to it. I know when we quantify something, we lose some information. Nevertheless, when we quantify, it helps us focus. So if you assume um, a, a certain developer hourly cost and say you do 50 number of builds per day, and if you can reduce the build time by 20 minutes, that adds up to a cost savings of $600,000 per year. It may not be 600,000, it may be 20% less, but it gives you the idea that the time saved per build adds up. So now the question becomes, where can we save these 20 minutes, right? Broadly speaking, for a CI/CD workflow, there is the build phase, the test phase, and there's the release phase. And through it all, over the course of using your CI/CD platform, you have setup and optimization. So related to setup and optimization, I wanted to start with this new functionality, new capability that you have with which you can chat with your builds. That's using the MCP server. How many of you here have tried using MCP server with any of your services? No? Cool. We have one hand here. That's awesome. So with Bitrise MCP server, what you can do is you can chat with the data and your builds in Bitrise from your favorite AI client. For example, like Claude Code or VS Code. And I just wanted to show you this because setting up VS Code, for example, to chat with your builds is fairly straightforward. Just open your user settings, that is Command Shift P or Control Shift P. Go to Open User Settings, then paste this simple JSON file, and you should have a workspace access token, which you can generate from Bitrise. And that's it. You can ask away the question to Bitrise. You just have to select agent from Copilot. Once you do that, you can ask the question. For example, how can I speed up my build? So I thought it would be interesting to have a small segment here, AI versus expert, to see how they compare and to make it a little interesting. So AI suggested, or Copilot in this case, suggested some ideas, and I crystallized them into three. One, enable Gradle parallelization. Two, use caching, or in my case, Bitrise caching. Three, try split and or parallel workflows. So this sort of aligns with the previous three phases I identified, the build, test, and release as well. So let's take a deeper dive into each one of them. First, let's build with the Gradle parallel flag, which is basically using org.gradle.parallel equal to true. And I am using the DuckDuckGo open source project here to get some metrics around it. And I'm running the compile debug unit test Kotlin, which means I'm just compiling the unit test for now. So here you can see this is a result from a sample run. I ran one here without parallel flag and one here with parallel flag. You can see the time difference It took 7 minutes for without paddle flag, and with paddle flags, it took only 6 minutes 51 seconds. So some time saved, and this is more pronounced if your Android setup is modular, so that within the VM, the modules can be built independently. It also depends on how your modules are, the dependency in your module setup. And this I ran on a Bitrise large machine with 8 vCPU and 32 GB of RAM. So I had this idea that let's try it on a bigger machine, which is a Bitrise XL machine, which had 16 vCPU and 64 GB RAM. You can compare the timing here. It was 6 minutes 51 seconds versus 3 minutes 49 seconds here. That means you save roughly 2 minutes. Then I thought, why not a bigger machine? So I tried with our largest machine, which has 48 vCPU and 192 GB RAM. And you can see that the time gain was not proportional. That means this large machine was not useful. So identifying the right machine type also saves you build time. So within Bitrise, we have the VM monitoring, where you can dig into the machine performance during the time of the build with CPU, memory, load average, etc. I want to zoom in to load average for these 3 builds. Here is load average. So what load average shows is load 1 here shows the average number of processes that is being executed or waiting to execute in 1 minute period. You can see that for half the build duration, there were more processes waiting to execute than the number of vCPUs available. We have 8 here, and there are more processes waiting to execute. Now let's take a look at the 16 vCPU. You can see that most of the processes executed below the availability level of 16 CPU, and there are only a few. That then it stands to reason that by increasing the number of CPU here, there is not much to gain. And that's what it shows here. With the 48 vCPU, you can see that there was so much capacity to spare. So by choosing the right machine, we saved an additional 3 minutes. And this is just for unit tests. Now, multiply that by 3, because you will see the same gain for integration tests and for release builds. That is, by choosing the parallel flag and by choosing the right machine type, you have roughly saved 9 minutes. Our goal is 20 minutes. Right. So that was a good collaboration with AI right here. Some ideas from our side, some ideas from AI side, and we're good. And the second idea that we had was to try to use Bitrise cache. We have 3 types of cache for Android within Bitrise for Gradle. We have the Gradle dependency cache, we have the co-located Gradle remote build cache, and Gradle configuration cache that's experimental right now. The dependency cache, it basically caches the dependencies that are downloaded. The remote build cache caches the outputs of the tasks, Gradle tasks. For each inputs, it caches the tasks. And configuration cache caches the output of the configuration phase. This is a little hard to pin down. It is useful in a small segment of builds. You can try it if it works for you. We are trying to make it more generic, which is why we have labeled it experimental for now. So most of you here have used Bitrise, so you know how a workflow looks like. To enable build cache for Gradle, you just have to add this step. To enable Gradle cache dependency caching, you just have to add these 2 steps and save and restore on top and save in the bottom. And for configuration cache, you have the restore Gradle configuration cache and save cache steps. So I did a run here with, so what you're seeing here is 4 independent runs run parallelly, 1 without cache, 1 with dependency cache, 1 with dependency cache and remote cache, and the final one with all 3 caches. Now the first run is not useful because the first run is creating the cache. It is not able to use it. So this is for the first commit, and then I ran the next run with the following commit. And that's and you can see these numbers. Let's deep dive into it. Again, this is with the DuckDuckGo project. You can see here that a remote build cache reduced build time by 35%. So that's useful. And now let's see what are the tools we have to drill down into the remote build cache performance. We have invocation details from where you can see how much was the cache hit rate. That is to say, how many tasks of the total tasks used cache. Then you can go further, drill down, and see the critical path that shows the list of tasks in critical path. It is useful to see in critical path what are the tasks that use cache and that did not. And if there is one, especially early on in the task execution, that can maybe use build cache, that can speed up your build. Now, this particular task was first executed, and if you want to see the reason why that task was first executed, you can enable diagnostic builds, which is another feature of build cache invocation details, and see the detail on why a particular task was first executed. These are analysis tools that you have. And finally, we have more capabilities to, for example, compare two different command executions. So in this case, I would like to compare this command execution, which had 50% hit rate, and this one has 43%. You can select them and compare, and it'll show you more details. We can help you analyze those executions. So that's the how you can drill down into Bitrise build cache. And there's one other point that I want to bring about the Bitrise build cache, remote build cache, is that it is co-located. It is located in the same data center as the CI runners, the CI machines. Therefore, it is slightly faster. Second, the data does not have to go out of the data center, so you don't have to have an additional egress cost associated with using build cache with Bitrise. And then you can see this small laptop and individual user here. This is to show that build cache can be used locally as well from a developer's on laptop. So the advantage is developer can speed up their builds by using the cache that is there in Bitrise remote build cache. All right, now let's look at the other two caches that we had. We had the dependency cache. In here, dependency cache really didn't help much, and the config cache also didn't help, because config cache is very, very subjective, and the way DuckDuckGo project is set up is the folders, the subprojects are identified dynamically, so every time it's run, the configuration cache changes, so that won't work. But let's take a deeper look at why dependency cache didn't help. So I thought we can have another AI versus expert segment. So why didn't dependency cache work? So I asked Copilot this question. It was pretty cool because it automatically connected to Bitrise. It downloaded the build logs. It compared the build logs and gave an analysis. It said that it saw that no dependencies were being downloaded, and that's why probably dependency cache didn't benefit. But unfortunately, this is not right. There were dependencies being downloaded, and the real reason was there was about 16 seconds gain in time, which was not worth the cache being uploaded and downloaded. So when you work with AI, we just have to be cautious. It is a useful tool, and that's just an illustration from these two cases that I had with using Copilot here. Right. So with build cache, we reduce time by 2 minutes. Again, we multiply by 3 because build cache can be used for the integration tests and release build. And therefore, at a total, we are at 15 minutes right now, about the amount of time saved. And now we have the third one, split/parallel workflows, right? And test sharding. So let's take a look at those. In this run, I tried to do unit test sharding, where I broke up the unit test into 2 shards, and I compared with a unit test with no shards, and there was no time gain with the DuckDuckGo project. That was because the amount of time mainly was spent in compiling, and the way the dependencies were, even though I sharded, pretty much the entire project was compiled, even for each shard, which is why there was no time saving for unit test shards. Now, for integration tests, DuckDuckGo had two flavors. They had the play flavor and internal flavor. So I ran the UI test shards per flavor all in parallel. And then here you can compare it with running those shards in running the both the flavors in parallel without shards, and you can see a substantial time gain with shards for integration test. It ran about 6 minutes faster with shards for integration tests. Both the flavors. You wouldn't typically run both the flavors at the same time, but you would probably run one flavor, and for each flavor, it gained about 6 minutes. So that's a total. Now, I just want to go back to the unit test scenario where we did not gain any time with the sharding with parallel workflows, but we are working, and it is available too with others, called distributed test execution, where you have dedicated auto scaling workers meant for testing alone. And you can distribute tests to these auto scaling workers. So we did, this is an alpha right now within Bitrise, and we saw that we could gain 2 minutes for unit tests, which we could not make any gains previously in our parallel workflows. Because these are dedicated machines, we could gain that. And this is useful, distributed test execution is useful if you have period of times with heavy testing load. So then you can have these dedicated workers during that time, and it'll save you time per build. Now, we can also, all the screenshots that you saw where I compared the different run times of different execution approaches, I ran each of those builds in parallel. So you can use that approach for release too. So based on your process, your workflows can be set up to run in parallel in multiple ways. In this case, I can run these 3 releases in parallel, and you can have the packages created for each one of them. And then you can use run if conditions to selectively run these workflows. So for example, if you want to run the play only if a certain file is edited, you can set it up that way. That way, when this particular pipeline, which is a series of workflows, is triggered, only the droid and internal will run. So with parallel workflows, we save 6 minutes. That is the integration test shards. So in total, we saved more than 20 minutes. It might vary slightly, but this is just to give you an idea that with these optimizations, you can save substantial amount of time in your build. And with the calculator earlier, you can see that adds up when you look at over the year period. And the final topic that I want to look at is AI in CI. That is how you can run agentic AI steps on Bitrise. This is a new development. Previously with AI, user had to wait and prompt and wait to see the response and interact with the AI. But with the agentic AI, it can run in iterations. And so running them in a VM and Bitrise is an ideal environment. So for example, we have the AI code reviewer step, which if it is a pull request, it can review the code changes in files and post feedback to the Git PR as a comment, which means the user who's creating the PR the developer will get feedback immediately and maybe can act on it. Another one that we have is the AI issue identifier. This can look, if there is an issue within the workflow, it can look at the code as well as the logs and suggest a solution. Now, we have other options where the key thing is that this code is limited to the virtual machine, so nobody else is seeing that. And this has access to both the logs and the code. Therefore, the solutions suggested tend to be more accurate. And this can be then sent over via Slack to your team so they can act on pretty quickly. So that's all I wanted to cover in today's session. If you have any questions, You can ask now, or you can find us at the booth right over behind stage 2 tomorrow. I guess it's almost the end of the day today. Um, so thank you. It was great to have you at the session today.